So in this question, let's see a problem for systematic cyclic codes. Okay, the question is for in 7 comma 4 systematic cyclic code, find the code vector for the message 1100 given the generated polynomial is g of p equal to p cube plus p plus 1. Okay, so for what from this what we see is uh, the question that is asked is to find the code vector using systematic cyclic codes. Okay, so in cyclic codes we have two kinds of problems. One is systematic and non-systematic. Okay, so generally to generate a code vector you might know that if a code vector is represented by x. Okay, so code vector is combination of nothing but message plus check bits, right? Message plus check bits, right? So the length of the message is going to be of k bits, and the length of the check bits is going to be of n minus k, which we call as q. Okay, so in the question n comma k is given, which is nothing but 7 comma 4. So n is nothing but the length of the code word, and k is nothing but the length of the check bits. Okay, so the length of 4 is nothing but the length of the message bit. Okay, so check bit is going to be of length n minus k, which is 7 minus 4, which is equal to be 3. Okay, so you hope you all know that for an systematic cyclic codes, the check bits is followed or after the message it is followed by the check bits. Okay, so we all know it is the length is going to be n minus k, which is 7 minus 4, which is nothing but 3. Okay, so the formula for finding the check bits, okay, just to know the check bits, you should know the check bits polynomial. So I'll write the formula for the check bits polynomial. So the check bits polynomial is obtained by C of p is equal to remainder of p of q into m of p by g of p, right? This is the formula to find the check bits polynomial. So once we know the check bits polynomial, we can easily find the check bits. Okay, we can find the check bits from the check bits polynomial. Okay, so given the message m, okay, given the message m1100, so m is given as 110. Okay, m is given as 1100, and okay, let's initially find the message polynomial. Okay, so message polynomial is given as, okay, so if this is 1100, we all know this is your m3, this is your m2, m1, and m0. Okay, so this is this format, and the message polynomial m of p is given as m3 into p3 plus m2 into p square plus m1 into p plus m0. This is your message polynomial. Okay, so from the question we know m is going to be 1100, that is m3 is 1, m2 is 1, m1 is 0, and m0 is 0. So from this we know we are going to have 1 into p3, this is p cube, this is 1, m2 is 1, it is p square plus m1 is 0 and m0 is 0 plus 0. So m of p is nothing but p cube plus p square, right? So then g of p, then we should know what is g of p. So g of p is given in the question, right? G of p is p cube plus p plus 1. So to find cp, to find the check bits polynomial, we should also know what is p cube, what is p power q into mp. So p power q is nothing but the value of q is nothing but n minus k. I told you, right? The q is nothing but n minus k. So the value of p cube is equal to p power 3. So 1 minute. Okay, so m into p cube. So we need to know what is p cube p power q into mp. So p q value is 3, mp is nothing but p cube into mp is p cube plus p square, which is going to be p power 6 plus p power 5. Okay, if it's power, you need to add 3 plus 2 is 5. So p cube and mp is p power 6 plus p power 5. So just to find cp, okay, cp is going to be remainder of p power 6 plus p power 5 divided by g of p is given the question is nothing but p cube plus p plus 1. Okay, p cube plus p plus 1. Now we are going to do a division. Okay, we are going to do a division and then find the remainder. Let's see how to find a division. So we need to perform division. So it is p power 6 plus p power 5, and here it is g of u, it is p cube plus p plus 1. Okay, so how will we do that? So to perform division, so first thing, here it is p power 6 p cube, so we need to add p3, right? So we need to add p3. So p3, if we add p3, this will be like p power 6, then p into p power 3 is p power 4. So it is 0. We don't have p power 5, so it is 0 p power 4. Sorry, 0 p power 5. 0 p power 5 plus 1 p power 4, 1 into p cube plus p cube, right? So that is p cube into p cube is p power 6, then p into p cube is p power 4. So we don't have p power 5, so write p 0 p power 5. Then we have like p power 4 plus 1 into p3. Okay, so here normally division we do subtraction, but here I need to do modulo to addition, like that is this basic XOR operation. So how will you perform XOR operation? You know that very well. Same sign means 0, different sign means 1. So 1 XOR 1 is 0, 0 XOR 0 is 0, 1 XOR 0 or 0 XOR 1 is 1, right? So if you perform, this is going to be 0. Okay, this is going to be 0 and this is going to be 0. What you're going to do is perform XOR operation. Okay, so this is going to be 0, right? So this is going to be 0. Then this is 1 XOR 0, that is 1, that is p power 5. Then we don't have anything here, so it is p power 4 plus p power q. Okay, so it is 0 plus p power 5 plus p power 4 plus p cube. So next thing we need to add is, if you want to divide, we need to add p power 2, right? So power of 3 plus 2 is 5. So let's do this. P power 5 plus p into p square, that is we don't have p power 4, so it is 0 p power 4 plus p into p square is p cube. Again 1 into p square is p square. Again it is going to be an XOR operation. Okay, so this is going to be 0, this is going to be p power 4 1, 0 XOR 1 XOR 0 is 1, so p power 4. Again 1 XOR 1 is 0, so it is 0 p cube, then we have p square. Okay, p square. So then how will you divide? So here p power 4, okay, we have p power cube, then we need to add p, right, plus p. Okay, plus p. So if you put plus p, p cube into p is p power 4. So p power 4 plus p into p is p square. We have p cube, so it is 0 p cube Okay, there is no p cube term, so if it's 0, then we have p square, so it is p square plus p. Okay, now if we do this, what you get is 0, again 0, 0, you get just p, right? You get just p. Okay, so the remainder is p. So you all know the CP, the formula is, we have seen here, the check with CP polynomial is, okay, remainder of p power 3 MP by CP. We have to just know the remainder. So the remainder is, the remainder is nothing but p, right? So we all know the length is n minus k, is nothing but 3. Okay, so in general, so CP is going to be CP equal to so length is 3, so it is C2 is p square plus C1 p plus C0, and what we have is p here, right? That means that the value of C0 is 0, the value of C1 is 1, and C2 is 0. So it is, if we want to know the check bits, okay, so the value of check bits C is nothing but 0, 1, 0, because we don't have any p square term. If there is any p square term, we will write as 1. The C2 value is 1, so we don't have any p square term, so it is 0. We have p term, so it is C1 is 1, and there is no the C0 term. Okay, so it is going to be 0. So we all know for systematic cyclic we are done for the message m is equal to 1100, right? And for this the check bit 010. So the code word is nothing but, for systematic cyclic codes, we know code word is nothing but combination of message plus check bits, right? So code word X is nothing but 110010. So this is the final answer for your this is a code vector. This is a code vector for the message 1100. So this is your message and this is your check bits. Okay, so let me revise once. The question is, for a 7,4 systematic cyclic codes, find the code vector for the message 1100 given the general polynomial pq plus p plus 1. Okay, so we should know the formula. For this we have the general polynomial. To find the code vector, we should know code vector is nothing but the combination of message plus check bits. So to know if you want to know the check bits, you should know the check bits polynomial, and the formula is for finding this check bits polynomial is remainder of p power q mp into gp. Mp is nothing but the message polynomial. So given the message, we can find the message polynomial. Okay, so where you got is pq plus p square, then multiplying this term, okay, and performing the division. Okay, performing the division. Okay, you need to find the remainder is nothing but the p. Then okay, substituting that, okay, you get the, combining that with the check bits polynomial, we have only the p terms, that is the only the p term is going to be 1, and C0 term and C2 term, C2 is going to be 0, 0, 1, 0. 0, 1, 0 is check bit, and if you know the check bits, we can write for a systematic cyclic code check bits nothing but a combination of message plus code vector is nothing but the combination of message plus check bits. It's like 1100 and followed by check bits 010. Thank you.